Hello, I'm Whitney Utley, and the information presented in this keynote comes from Deanna Kuhn's The Development of Causal Reasoning. What is causal reasoning? Kuhn explains that causal reasoning is a way in which we categorize and explain causes and effects in order to make sense of the world around us. Is there a one-size-fits-all when it comes to developing causal reasoning? Researchers have tried to identify a set of inference rules that can be applied to understanding how adults reason causally. However, it would be challenging to capture the variance in individual adults' lives in order to apply a said set of inference rules that could explain how causal learning is developed. So no, there is no one-size-fits-all. Research has shown that children's causal reasoning is far more proficient than adults' causal reasoning. Researchers have also determined that the task to learn causal reasoning is so complex that it cannot be developed just from experiences children encounter alone, and that it must be supplemented with complex inference rules. The essential question Kuhn asks is, how do these inference rules for identifying causes and effects change from a childhood to adulthood? The process of causal learning starts at infancy. Causal inference develops early on in infants. Within the first year of life, infants develop expectations and express surprise when these expectations are handled differently than expected. They recognize that if they move their legs attached to a rattle, that it will make a noise. The infant's own actions are the first building block to causal inference. Infants then recognize causal connections that occur outside of themselves. Soon after the first encounters with their own actions and causal inferences, they are able to recognize these causal connections that happen beyond themselves. Researchers discovered that children are able to make sense of the world around them by identifying outcomes and finding the cause by backward reasoning. Children are less concerned with making predictions and more about why things have happened. Predictions do not drive causal learning because they cannot provide new theories. Thus, children develop a sense of their world by establishing satisfying explanations to outcomes they encounter. Kuhn posits that the way in which we identify causes and effects changes as we develop. Both adults and children update beliefs and ideas as new evidence arises, especially when our expectations are not met. However, a process of comparing the new information to already held beliefs must occur in order to accept new information. This is how both adults and children learn. Adolescents struggle with predictions and causal reasoning. Research on adolescents showed that they were slower to use their reasoning and put it all together when it came to making sense of a new situation when they were presented with a certain task. However, Kuhn explains how research also showed that although adolescents' performance on such a task that required them to use their reasoning abilities was poor, that they had rapid progress in learning causal reasoning. In conclusion, early adolescence is a good time to provide intervention in reasoning skills. Studies showed great variation in results from adults compared to 12-year-olds on a reasoning task. This shows that individuals and their different background knowledge and experiences should be taken into account when it comes to examining the development of causal reasoning. This information reveals that causal reasoning and its development should not be given a universal model and set of steps in order to be mastered. In her article, The Development of Causal Reasoning, Deanna Kuhn recommends that emphasis on reading, representing, and reconciling skills for reasoning should be taught to children in order to strengthen reasoning skills, since studies have shown that adults struggle with it. She further explains that children should be encouraged to build and revise their explanations in order to make sense of the world around them.